So in this part of the lecture, we'll discuss how we can derive a wave equation from the source-free Maxwell's equation. So let's remind ourselves what the source-free Maxwell's equations are. So we have, we have curl of E is equal to minus delta B by delta T. So this is Faraday's law. And then we have curl of B is equal to del E by del T, and this is Ampere's law. And then we have Coulomb's law or Gauss's law. And then we have the absence of magnetic monopoles. So let's just derive a wave equation for the electric field. So what we can do is that we can take the second equation, this guy, and take a time derivative of this equation. So if I take the time derivative, then I have del squared E of del T squared, and then we will have the curl of del B by del T. So I'm assuming that partial derivatives commute, and therefore, when I apply d by dt, it commutes with del. So then what I can say is that, but here the time derivative of B can be read off from Faraday's law. So I can use Faraday's law, and then I should be able to get minus curl of E. Now, if you go back to your vector calculus and you say, okay, if I have some vector f and I apply the curl on this twice, what do I get? Well, the answer is you get a gradient of the divergence of f minus the Laplacian of f. That's what you get. So this is a vector. So if I apply this to my equation, then I get del squared of E, del T squared is equal to minus, the minus stays in the first term, I get a gradient of a divergence of E, and then I get on the second term, I get plus del squared of E. But what is divergence of E? Because it's a source-free equation from Gauss's law, we see that that's 0. And so we get, as a result, a wave equation from Maxwell's equation, and we are using units in which the speed of light, c is 1. And Maxwell was able to show by deriving this equation that light is an electromagnetic wave. Similarly, you can derive an equation for the B field, which will obviously look something like this. Okay, so these are the wave equations that you can derive from Maxwell's equations.